Hello again, everyone. I've got a video for you about angles, a very fundamental and important concept in all of math and even extending out into various branches of science and just life in general. But anyways, I wanted to cover some basics about angles that you'll encounter in geometry. So I want to start by telling you, what does it even mean to be an angle? That'd be a really great question that you might encounter from a teacher or something like that, where you're doing all this stuff and you might just stop and say, wait a minute, what does it even mean to be an angle? So let's cover that really quickly. First of all, an angle is really formed, as I've written here, by two rays, or it could also be formed by two lines, as you can see, extending from a common vertex. Now, it's usually named with letters, but it doesn't have to be English letters, and it certainly doesn't have to be just letters, as I will show you. So here's some examples. I've got a vertex here. So when I say vertex, I'm talking about this point where these two rays meet. And a ray is just starts and only extends forever in one direction. Okay, so these two rays, they both share this common vertex or endpoint, and the space in between them forms the angle. So this is just some random angle. I've got another example for you here using lines that go on forever. They meet here and they form a lot of different angles. So all of these spaces here, 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 and here are all different types or examples of angles. Okay, so with that in mind, let's talk really quick about naming angles, because that's important. You're going to see different ways of naming even the same angle when you're in class. Okay, so what I've written for you here is to keep the letter of the vertex in the middle. Now I'm going to describe exactly what that means, and I'm going to name these angles as well. I'm also going to classify them, kind of do this all in one shot. Okay, any angle that is less than 90 degrees, we can go ahead and call that an acute angle. So this one is definitely an acute angle. The vertex is given by point E, so I can just say that this is angle E. This symbol here is one possible symbol that you could see to represent the word angle. So literally this sentence is a combination of English and math, where it says acute angle E. Okay, so another way that you could have seen it is with just that symbol right there. This symbol also means angle. I would probably be careful using this symbol. It's okay if you do that, but only for one reason. I don't want you to get confused if you quickly write it like this, because this actually means less than. So it's okay to write angles using this symbol. Just make sure that you don't get confused with less than. So that's why I think this one came about with the curve in between, or in the, kind of going through it, so that people wouldn't get confused about what symbol they're actually writing. Okay, so same angle over here as this one, except it's got 3 different points on it, and we can name it several different ways. Still an acute angle. Now, keep the letter of the vertex in the middle. That is absolutely important, because if you don't do that, you haven't named this angle correctly. So here's my vertex. Point E. So therefore this is acute angle DEF. The point of my vertex staying right in the middle of the other 2 letters. So if you're watching this, you might be thinking, well, I didn't necessarily do it that way, but I still kept the letter of the vertex in the middle, and you are correct. There's another way that you can write this. It's angle FED. Good old Fed. So you still have angle E as part of the vertex. It's right in the middle of the other 2 letters, and it accurately represents this angle. And of course, the other way you could have written it, because there are no other angles attached to this, if you just said it's just angle E, you are still correct. Okay, so this angle over here, no longer an acute angle. Any angle that is greater than 90 degrees is obtuse, an obtuse angle. Okay, so This angle being obtuse, there really is only one way to name this angle because there are no letters. It's just this and a number here. So I can just call this obtuse angle 2. So there you have the naming of angles is important because when you're in geometry, you'll see situations like this happening all the time. Lots of letters, lots of numbers, different angles being shared, with or sharing a vertex. So the naming is important for you to understand so you don't get confused and lost in a diagram. It's very easy to do. Just keep at it, keep practicing it, and you'll be just fine though. I have full confidence. Okay, so now let's talk about how we can apply angles in certain situations and what happens in certain diagrams. So let's say I've got two parallel lines here. This kind of combines, I'm going to be combining concepts from a different video. From a different video, I described what it meant to be parallel lines. They never cross. This line going through here is a transversal. So that's important because now all of a sudden we have a bunch of different angle relationships that we can name. So what I'm going to do is I'm going to start naming these angles, and I'm actually going to use numbers. So this is going to be angle 1, 2, 3, 4, and then 5, 6, 7, and 8. So now I have all of the angles that have formed, even though I didn't actually fill in the vertex here and here. These are still valid angles that are being formed from the parallel lines and this transversal going through. This is a very common setup you're going to see in geometry. Okay, so what angle relationships are going on here and what are they called? What are the fancy schmancy million-dollar words that geometry is going to throw at you to describe what is happening here? I'm going to tell you. First of all, you have what's called alternate, and we'll start with exterior angles. Now, I'll use this to abbreviate to save time and space, and that is oftentimes what you will see a lot of teachers do. In fact, they'll even abbreviate these words, but I've written them out for you here so you know exactly what I'm talking about. Okay, first of all, the word alternate. You have an idea of what that means, and it's the same meaning here. Alternate being different or opposite. You could even think of them as maybe kind of an extreme case, but in geometry, this is kind of the meaning it takes on for alternate. So, two angles, let's figure this out, that are alternate. You might think, okay, well, this is 1 and 2. Yes, but for our purposes, what we're going to do is we're going to think in terms of angles that are along this line. So, two angles that are alternate, if I look at this line, would be like, say, 1 and 3. Those are directly alternate from each other on this line. 2 and 4 as well. But we could also do these other angles here, like, say, 1 and 7, 1 maybe even to 6, just because they're on different sides of the same transversal line. That's going to make them alternate in a geometry sense. Okay, so then let's go to the other word to kind of narrow down what we're talking about. Exterior, outside, on the outer. So if I combine these two concepts of, okay, being on the alternate or on different sides of the outside of this line right here, that gives me only a couple of different options. Angle 1 and angle 7. So first of all, angle 1 is kind of over here on the left side of this line. Angle 7 is over here on the right side of it, so that makes them alternate. Why did I pick 1 and 7? Because both angle 1 and angle 7 are on the exterior when it comes to these parallel lines right here. They're kind of like on the outside, a nice view of the sky, view of the ground. That makes them exterior. Okay, so angle 1 and 7 would work, but there's more than that. We could also have, say, angle 2 and angle 8. So these are my alternate exterior angles right here, 1 and 7 being on opposite or alternate sides of this transversal, and 2 and 8. Now, what does that matter? What does that even tell us? Well, it tells us that in geometry, these angles are exactly the same, or as we say with this symbol, congruent. It means they're exactly equal. So whatever angle 1 is exactly the same as the measure of whatever angle 7 is, and it goes the other way. If you knew 7 and you didn't know 1, you could just say, well, by alternate exterior angles, angle 7 is the same as angle 1. Same thing for angle 2 and 8. But that is not the only relationship of the angles that we have here. We also have alternate, and I will now abbreviate that, interior angles. And with alternate interior angles, we're going to approach this in very much the same way we did alternate exterior. The only difference is we're looking for angles that are inside of the parallel lines. So any angles that are trapped inside the parallel lines but still on alternate sides of this transversal. Okay, so that looks like it's going to be angle 4 because it's kind of underneath or trapped inside of the parallel lines. And an alternate angle from that would be angle 6. So angle 4 and angle 6, they're both inside of kind of these parallel lines, and they are on alternate sides of that transversal right here. So I'm looking for ones that are kind of like catty corner across, same as I did for the alternate exteriors. Because you think, well, 4 and 3 are on alternate sides as well, but the relationship of alternate exterior and interior is more of a what's going on with the catty corner across one. So that's also going to tell me something about angle 5 and angle 3. So just as I had for the exterior, alternate exterior angles being congruent, that's also true for the alternate interior angles. So this is a very important thing in geometry, that you have a bunch of angle relationships happening here, and basically what it comes down to is that they are congruent. The exterior angles are going to be congruent, especially the alternate ones, only the alternate ones, excuse me, and the alternate interior angles will also be congruent. So that's very helpful. If you say you know this angle, you can just say, well, this one's exactly the same as that one by the alternate interior angles. So this is just some of the relationships that you have here. There's even more that I will describe in a different video. Thanks for watching.